basic requirement of security is confidentiality. Okay, based on NASP. NASP is a standard for various protocols and techniques in the perspective. Based on NASP recommendation, security is defined by three things: confidentiality, integrity, and availability. So the first thing is confidentiality. Okay. So what is the confidentiality? The data, service, or the source should not be disclosed to the unauthorized person. Okay. For example, if the data is transmitted from one computer to another computer from internet through public network, so anybody in between can tamper the wire or can process the wireless medium to capture the data. Okay. So now the confidentiality, ensuring the confidentiality means the data to be received only by the intended recipient, not by others, even if it passes through the public channel. Okay.
Ma'am, some disturbance in your voice, ma'am.
Is it clear now? Now is it clear?
Yes, ma'am.
So confidentiality
Yes, ma'am.
the data should not be disclosed to the unauthorized person. Okay, even the data transmitted through the public channel. Okay, public network or public channel, the data or resource should not be exposed to the unauthorized person. To enforce confidentiality, before 1977, one basic architecture was used, which is symmetrical cryptography. But now we have two different architectures, one is symmetric and asymmetric. To enforce confidentiality, we can either use symmetric cryptography or asymmetric cryptography. But after understanding symmetric cryptography, you will know, and definitely you can understand the drawback of using symmetric cryptography that this is later. The architecture behind this is very simple. The reason for the symmetric cryptography is to provide confidentiality, just confidentiality, okay, not integrity or availability. When the data is transmitted from one computer to another computer, the data is not disclosed, should not be disclosed to the unauthorized person. That confidentiality is ensured by using symmetric cryptography. Okay. So in the first unit, we are going to discuss about some classical cipher. What do I mean by classical cipher? Cryptography is not advertised in cryptography, even used in World War I and World War II. Okay, very first cryptography was developed by Julius Caesar. And in World War II, Britain and Germany, they were used to so many different systems for sharing of secrecy or sensitive data. Okay? So it's not a new thing, but it comes through so many evolution. There are so many changes. Because in World War II, we used one predominant crypto system used by a US Britain Army, that is known as a flavor cipher. Okay, but the thing is that those days the algorithms also secret. The algorithms are also secret. Okay, but nowadays everybody knows about the algorithm. You can easily understand the AS algorithm. You can easily understand DS algorithm. So algorithm is not secret. Encryption process is not secret. Decryption process is not secret. It's available. Okay, but in classical cipher point of view, the algorithm is also secret. Okay, the character sets, jumbled character set will be available with the intruder, hacker, and some sort of approach to be used on that character set to recover the information, some semantics out of it. Okay, so symmetric classical crypto system point of view. Those crypto systems are used by the classical, used by the various perspective. But those days, algorithms were also secret. But now, symmetric crypto system, the algorithm is not secret. Okay? But why do we need to understand the classical cipher? The classical cipher provides some understanding on the way in which the crypto system to be designed. Okay? So that's why for the first 4 consecutive days, we are going to discuss about various classical ciphers like Julius Caesar cipher, Visionary cipher, Hill cipher by Hill, and so many different classical cipher that were used in the year 18th century and 17th century. But it's no more. But the understanding of Hill cipher is important so that you can better understand the modern cipher. So modern cipher design aspect is based on classical cipher. Okay, all the classical ciphers are symmetric cipher. Okay, so you should know what is symmetric. What is symmetric cipher and what is the idea behind the symmetric cipher. So, symmetric cipher, I can define it like this. For example, we have the sender, Newton, Alice. Okay, Alice wants to send a message to Bob, a sensitive message to Bob. Okay, Alice and Bob connected through a public chat. Okay, so Alice and Bob connected through the public insecure chat. So now, Alice need to transmit the data. The data will transmit it through this channel. Okay. So now here, this channel is publicly available. So we have the intruder here, the dark or intruder. So dark is capable of tampering this wire, can tamper the wire. So whenever the data is transmitted as a raw data, it's visible to dark. Okay. So here there is no compression. Underlying TCP/IP protocol, it won't provide compression. So we need to provide confidentiality by exploiting symmetric cipher. Okay, so the procedure is some action to be performed in a sender side. Alice need to perform something. Okay, Alice need to transform the data, and the transform the data will be transmitted over this channel. And after receiving the data, Bob need to recover the data. Okay, this Bob need to recover the data. So there are two algorithms are involved. One is the given data, the plain text, the actual raw data is known as plain text. Okay, so the actual raw data is known as plain text. Okay, so the plain text cannot be transmitted over this channel because there is no confidentiality. Okay, so the plain text to be transformed into a jumbled character or not understandable character. That is again character. If it is, for example, if the plain text is an English alphabet, ciphertext is also English alphabet. If the plain text is binary, ciphertext is also binary bit stream. Okay, but what is the ciphertext? From this ciphertext, you cannot recover any semantics, not recover any meaning of that text. Okay, so the plain text to be converted into ciphertext. Okay, so now that transformation is to be performed by Alice. Okay, so it's not unreadable form. The plain text, if the plain text is binary, ciphertext is also binary. It's not a special character. Okay, if the plain text is English alphabet, ciphertext it cannot be the Tamil alphabet or some other alphabet. Ciphertext should also be English alphabet. Okay, the thing is that the plain text is having some semantics, some meaning. Okay, but in ciphertext it is not possible to find out the meaning of the text. Okay, so that transformation to be performed by Alice. Okay, after doing this transformation, the ciphertext to be injected onto this circuit. Okay, so to perform this transformation, Alice need to perform, Alice need to apply an algorithm called encryption algorithm or encipherment. Okay, so encipherment is a function that will transform the plain text into ciphertext. Okay, in a similar manner here, B, upon receiving this ciphertext, the plain text to be recovered because the intended recipient is B, Bob. Okay, so the transformation of ciphertext to plain text is known as decryption. Okay, so encryption is a function and decryption is a function. Encipherment is a process by the encryption function. Decipherment is a process by the encryption function. Only one change is that encryption takes plain text as input, ciphertext as output. Decryption takes ciphertext as input and plain text as output. Okay, this is known as function. Okay, one-way function. Okay, so if you define the function like this, I said already these algorithms are public. Okay, so dark can also know this function, encryption function and decryption function. So dark can also do this type of transformation. Upon receiving the ciphertext, dark can also recover the plain text. Okay, so we have to convert this function as a one-way trapdoor function. Okay, one-way trapdoor function. What is the trapdoor? Okay, so the function is known as trapdoor. All these terminologies are important. Trapdoor function, general function, normal function. It's not possible with the cryptography. We need a trapdoor function. Okay, what is a trapdoor function? I can define it like this. Okay, encryption. Okay, encryption of plain text. This is ciphertext. Okay. Now here I'm going to represent this in the mathematical form. Decryption of ciphertext provides plain text. This is function. Okay. So what is a trapdoor here? Trapdoor here is to perform this transformation, plain text to ciphertext, we need additional extra data. One trapdoor is required. The trapdoor is known as key. Okay. So here also, to recover plain text from the ciphertext, we need a trapdoor. Okay, trapdoor to open the function, we need another extra sensitive data, that is K. Okay, so as long as the K is secret, between A and B, that cannot open the data because D is known only to A as well as B. Okay, so D of C with K provides P. Okay, so it's completely impossible to derive P from C without A. Okay, so this type of functions are known as trapdoor function. Okay, so cryptographic perspective, we need a trapdoor function. Okay, and moreover, it's completely it won't make any changes in the plain text. Okay, the plain text to be completely recoverable. Even a bit of data should not be corrupted. Okay, so here symmetric cryptography, if both the keys are same, then that type of crypto system is known as symmetric crypto system. Okay, so crypto system has two things: encryption algorithm, decryption algorithm. Okay, if both the keys are different, for example, allies can use one key to perform this transformation, plain text to ciphertext. Bob can use different key to perform the transformation of ciphertext to plain text. That type of crypto system is known as asymmetric crypto system. Okay, so symmetric crypto system design aspect is completely different from asymmetric crypto system. Design aspect of asymmetric crypto system is completely different. Okay, so for time being, don't worry about asymmetric crypto system. Just concentrate on symmetric crypto system. In symmetric crypto system, symmetric or secret key crypto system, Alice and Bob needs to use the same key for encryption as well as decryption. Okay, so decryption is completely simply a reverse process of encryption, nothing else. Okay, but this is not true with asymmetric. Okay, so decryption is a reverse process of encryption. Okay, so here encryption algorithm is not secret. Decryption algorithm is not secret. Okay, but what is the secrecy here? What is this? And ciphertext is also not secret. Ciphertext transmitted over this public channel. Okay, ciphertext is also not secret. Okay, so ciphertext is available, encryption algorithm is available, and decryption algorithm is also known to DART. Based on those things, the DART need to recover plain text without using. That is completely impossible with the symmetric cipher. Okay, so symmetric cipher in the sense, sender will convert plain text into ciphertext by applying encryption algorithm with a key. Upon receiving the ciphertext, receiver decrypt the data by using the same key, so that the plain text will be recovered. Okay, so the DART can receive this. Okay, DART can tamper this wire. What are the things that are possible with the DART? DART can tamper this wire, and DART will get. Okay, let me write the equation. Alice will compute a plain text E of K is C. Okay, C is transmitted over this. Now C is available here. So now Bob will compute E of C with K is equal to. Okay, so in this channel, what is traveling in this channel is C. Okay, so DART will receive C. From using the C, DART need to recover the data because it is confidential. What is confidential here? E is confidential. Okay, so the hackers or intruder perspective is from given C, DART need to recover plain text or need to find out the key. Okay, so this is known as encryption algorithm. Okay, transformation of plain text to ciphertext is known as encryption algorithm. Transformation of ciphertext to plain text, that process is known as decryption algorithm. And the transformation of ciphertext to the plain text or key. Okay, so this process is known as cryptanalysis. Cryptanalysis. Okay, so this is encryption. This part is encryption, and this part is decryption. And opponent or intruder perform cryptanalysis. Okay, clear? Any doubt?
Clear, ma'am.
Okay. So now in this case, before getting into the classical ciphers, some more basic terminologies are required. Let's get into this. When you design symmetric cipher, some basic characteristics to be explained. Okay? So symmetric cipher, we are talking about symmetric cipher. Okay. So the crypto system. What is crypto system? Encryption algorithm, decryption algorithm together known as crypto system. Okay. So the crypto system can be the product cipher. One basic property is product cipher. Okay. So what is the product cipher? Product cipher is a characteristic for symmetric crypto system. Actually, when you design a symmetric crypto system, the encryption is a process. Okay, that encryption process is based on two basic operations. Symmetric cryptographic perspective. Okay, not based on asymmetric cryptographic perspective. In symmetric cryptographic perspective, encryption is based on one and two basic operations. Okay, the first operation is known as substitution. Second operation is known as permutation or transposition. Okay, for example, let us consider input as Shastra. Okay, so substitution means this is the plain text. I need to convert this one into ciphertext. Okay, substitution means each and every alphabet to be replaced by some other alphabet. Each and every alphabet based on encryption algorithm. Okay, each and every alphabet to be replaced by some other alphabet. For example, if it is a bit string, binary bit stream, each and every bit to be replaced by some other bits. Okay, permutation means the location of the character to be shifted. Okay, each and every character to be transposed or relocated to some other place. For example, it is a word with 6 characters. The first character may be permuted to the third character, fourth position. Okay. Second character may be permuted to the first position. Third character may be permuted to the fifth position. Changing the position alone is known as permutation. Okay. So replacing the character by another character is known as substitution. Changing the position of the character is known as permutation. Now you can ask one question. Why this substitution and permutation? Cryptography is based on strong mathematics. Okay. Symmetric cryptography is based on a strong mathematics called the Shannon theory. Shannon theory. Okay, invented by Shannon in the 18th century. Okay, in Shannon theory, it provides two basic definitions. One is known as confusion, another one is known as diffusion. Okay, confusion and diffusion. What is confusion and diffusion? For example, if you want to design a secure crypto system or best crypto system or attack resistant crypto system, we need to enforce confusion and diffusion property. What is a confusion diffusion property? If you take any crypto system, there are 3 elements are required. What are those? Plain text, ciphertext, and key. Okay. So the Shannon theory is a design aspect for encryption decryption algorithm. Okay. So plain text is input, ciphertext is output, K is an additional trap or secrecy. Okay. The decryption process, plain text is output, ciphertext is input. Okay. What is confusion? Confusion means in order to provide a efficient crypto system or attack resistant crypto system, we have to break the relationship between plain text and ciphertext. Okay. I think now you may have some confusion about the relationship between the plain text and ciphertext. I will tell you when we discuss about binary cipher or monoalphabetic cipher. There is a relationship between plain text and ciphertext. If you apply plain cipher or fill cipher or some other cipher, we have to break that relationship because attacker, cryptanalyst will exploit that relationship to derive the key, okay, or to break the crypto system. So we have to break the relationship between the plain text and ciphertext. That is one important property. And another property is we have to break the relationship between the key and the ciphertext. Key and the ciphertext. Okay. So this is known as confusion property, and this is known as diffusion property. Okay. So breaking the relationship between the plain text and ciphertext is known as confusion. Breaking the relationship between the ciphertext to key is known as diffusion. This is based on a mathematical concept called Shannon theory. Okay. So In order to provide confusion, you need to incorporate substitution. Substitution is a requirement. And in order to provide diffusion, we need to incorporate permutation. But whatever may be the symmetric crypto system, AES or DES, even modern symmetric crypto systems are also built on top of substitutions and permutation. Okay, some complex substitution and permutation. Okay, but simply substitution and permutation, no other mathematics. Okay, so symmetric crypto systems are based on a basic operations called substitutions and permutation. Basic building block of any symmetric crypto system: substitution, permutation. That's it. Okay. Now, what is product cipher? Let us assume an encryption algorithm is defined in terms of substitution and permutation. Okay. So let me take that as a function. Okay, I have defined the function. That function takes plain text as input, produces ciphertext as output. That function defines the way in which the substitution or permutation to be performed. Okay. So to build a strong symmetric crypto system, the crypto system should be a product cipher. What is a product cipher? The same function or a different function to be applied again and again. Okay. So encryption, let us define it like this. Okay, I have the plain text P. Okay, the input is a plain text P. The decryption algorithm will produce the output C. Okay, so now if you apply a function only once, it will produce some value. Okay, so the same function or similar function to be applied again and again. The output is given to the function. Okay, the output of this will be given to the same or different function. Okay, so if you define the crypto system like this, that type of crypto system is known as product cipher. Not based on one simple operation, it is based on repeated operation. Okay, so the repeated operation, most of the symmetric crypto system, the strength of the symmetric crypto system is based on how many times you are repeating this. That is known as routes. Okay, if you repeat the task again and again, if number of times are high, security strength is high. Okay. And modern symmetric crypto system, AES is based on 10 rounds of operation. Okay, actually we have 3 versions of AES. Minimal security AES is based on 10 rounds of operation. Each round is one function. The function to be applied again and again 10 times. Okay, so the reason is that in order to avoid cryptanalysis or attack against the crypto system. Okay, number of rounds are high, security strength is high. Okay, so product cipher means the same operation, the same transformation to be repeated again and again in number of times. So that is a characteristics, required characteristics for symmetric cipher, not for asymmetric cipher. Asymmetric ciphers are all the asymmetric ciphers are based on single round of operation. Okay, but symmetric ciphers are based on same operation to be repeated several times. So that is known as product cipher. Okay, and another basic terminology. Most of the symmetric ciphers are block cipher. Okay, we have 2 different types of cipher. One is the block cipher versus stream cipher. Stream cipher. Okay, so block cipher versus stream cipher. What is block cipher and what is stream cipher? For example, let us take Alice. The encryption algorithm takes an input of plain text, produces the output ciphertext, and another input required here is EP. Okay, and equivalently we have a decryption process. It takes ciphertext as the input and plain text as the output. Another element is okay. Some crypto system like AES, GES, it works on a block of data. Okay, so AES it will take 64-bit plain text. Okay, this will be 64-bit plain text. Okay, it produces 64-bit ciphertext. Okay, T is also of type block 56-bit. AES 128-bit input, 128-bit output. Okay, so it works on a block of binary data. It need not be binary. A block of alphabet character, a block of Sanskrit character. Okay, if it works on 8-bit character or a 12-bit character, 64-bit character, 128-bit character at a time, that type of crypto systems are known as block cipher. Okay, for most of the applications are based on block cipher. For example, when you transmit the image from one machine to another machine, encrypted image, you take an entire image, you encrypt it, and the noisy image will be transmitted over the channel. Okay, that's one example for block cipher. Stream cipher Stream Cipher works on a single bit at a time. Okay, real-time streaming data. If you take multimedia data, on-demand video or on-demand audio, the system will accept one bit at a time or one character at a time. Okay, so upon receiving each and every character, that character will be converted into ciphers. That type of ciphers are known as stream cipher. Okay, so there is no change in the algorithm. The input is in the block cipher, it works on a block of data, but stream cipher it works on a bit or byte at a time. Okay, so stream ciphers are suitable for real-time data transmission, real-time data, real-time application. Block ciphers are suitable for traditional file transfer, HTTP, SMTP. All the applications are based on block cipher. We need to transmit a block of data. We need to transmit the image. We need to transmit a text. Okay, so those things are based on block cipher. Stream cipher it works on one bit at a time, one character at a time, one bit or one character. Okay, it works on real streaming data. Real streaming data. Yeah, I can give you the definition like this. We need to encrypt the data as it arrives. Okay, in block cipher, take the data, completely receive the data, divide the data into blocks, and encrypt each and every block separately. Okay, that is block cipher and stream cipher. Block cipher versus stream cipher. Okay, clear?
Yes, ma'am.
Okay. So next, these are the two important terms related to symmetric cipher because most of the symmetric ciphers are product cipher. All the symmetric ciphers are product cipher. Symmetric modern ciphers are product cipher, and all the modern symmetric ciphers are block cipher. Okay, so then you need to know what is block cipher and symmetric cipher. Okay. And next, we get into one more component. Cryptanalyst point of view, a dark point of view. Okay, so cryptanalysis of symmetric crypto system. For example, symmetric crypto system. Okay, in symmetric crypto system, a dark intruder hacker need to recover key K. Okay, because K is unknown. Okay, so we need the dark need to recover this key, otherwise plain text from the ciphertext. Okay, so unknown thing is unknown component, plain text to be recovered. Okay, and another unknown component is key. What are the known elements? Known things are encryption algorithm is known to hacker because it's public. Encryption algorithm is known to hacker is also publicly available, and ciphertext because ciphertext is transmitted over the public network. So these are the known thing. Unknown thing is and. Okay. Now the dark can recover P, okay, or K by using any one of the two methods. First method is known as by exploiting algorithmic aspect of encryption and decryption process. The dark can recover the key that approach is known as cryptanalysis. Okay. And another way to break the crypto system, breaking the crypto system is deriving unknown from. Okay. Another way to break the crypto system is known as brute force. Okay, what is brute force? Brute force means trying all possible combinations of. Okay. Normally, we'll design a key in such a manner that brute force is completely not possible. Okay. So brute force, it won't require any extra knowledge or any extra mathematical skill or extra power is not required to derive this unknown. Just try all possible combinations of key. Definitely one will get that. Okay. So brute force is trying for. Cryptanalysis means by exploiting the weakness of encryption algorithm and decryption algorithm to recover K and that is known as cryptanalysis. Okay, this cryptanalysis requires extra knowledge, extra mathematical skill, extra power. Okay, so cryptanalysis are brute force, two different methods to derive key or plain text from encryption algorithm, decryption algorithm as well as ciphertext. Okay, so brute force I said no need for any extra power, but cryptanalysis requires extra knowledge. Okay, so based on the availability of the data, we can classify the cryptanalysis into 4 different types. There are 4 different ways of doing cryptanalysis. Okay, so the first one is for time being, inner about brute force because brute force requires trial and error approach to find out the key. Okay, but cryptanalysis is a mathematical approach. So, and the cryptanalysis are divided into four different types. For symmetric cryptography perspective, four different types of cryptanalysis are available. One is known as the first one is known as ciphertext only attack. Ciphertext only attack. Okay. So the ciphertext only attack, the hacker or intruder will get only ciphertext. Okay. So based on the given ciphertext, the hacker need to recover P. Okay, by exploiting, by designing an algorithm. This is actually higher level security because ciphertext only attack it's completely impossible for modern symmetric crypto system. Ciphertext only attack because cryptanalysis based on the available information, the cryptanalysis can do the analysis efficiently. Okay, if the input which is given to the cryptanalyst is high, then the possibility of breaking the crypto system is high. Okay, so in the first case, the input available with the cryptanalysis is very simple, which is ciphertext only. Okay, so from C, need to recover P. Okay, that requires very strong, complex cryptanalysis algorithm. Okay. Second type of attack is known as known plain text attack. Known plain text attack. Known plain text attack. So in this, the dark will get because allies, war, communicates. Okay. So the communication channel C is available. Now dark is here. Okay. So the first case, dark will get only ciphertext. The C alone is available. Okay. The known plain text attack, the dark will get extra data. That data is for some plain text, some other plain text, not this plain text. Okay. So for some other plain text, let it be this is P prime. For some other plain text, its equivalent ciphertext is also available for the same key. Okay. So not dark need to recover P, otherwise K. Both are unknown, still unknown. Okay. But dark, very simple thing is dark might have collected some extra data from others. Okay, so P prime is another plain text which is available. For that plain text, the equivalent ciphertext is also available. Okay, so not need with a single pair. We get more than one pair also. Okay, so this extra data is also exploited by dark to recover K or P. Okay, so this is known as known plain text attack. Okay, and second type of attack is known as chosen plain text attack. Chosen. Okay, the chosen plain text attack means the difference here is chosen plain text attack. Chosen plain text attack. So in the chosen plain text attack, the previous case, the known plain text attack, this P prime is not selected by the dark, not selected by the cryptanalyst. Okay, but here dark can select some plain text. Okay, normally the frequently used text is selected by the dark. Okay, so some chosen plain text and the equivalent ciphertext is also available. Okay, so what way it differs from this in known plain text attack, some pair of plain text and ciphertext already available that is exploited, that is being exploited. Okay, but in chosen plain text attack, the cryptanalyst can choose the plain text pattern. For that pattern, appropriate ciphertext will be given. Okay, so the frequently used word or some word which is common in the transaction can be exploited by the dark. Okay, so that extra data to be used by the dark to recover P or K from C. Okay, so these are the three things, and the next level of attack is known as known ciphertext attack. Known ciphertext attack. Okay, so known ciphertext attack, some common ciphertext and its equivalent plain text is available with the dark. Okay, some commonly used ciphertext and its equivalent plain text is available. With this extra data, dark need to recover plain text or key. Okay, so normally this type of information it is very hard acquire this data. Once you get this data, then we can design a very simple algorithm to break the process. Okay, so the final level of extra information to the hacker or intruder is chosen text attack. In some books, it's referred as chosen ciphertext, but it is not so chosen ciphertext. It is chosen text attack. Okay, what is the chosen text attack? Chosen means the data to be selected by cryptanalyst. Okay, so the cryptanalyst may choose some data or some plain text and ciphertext chosen by dark or cryptanalyst. Okay, then the equivalent plain text, the P prime, its equivalent plain text is available, and for C prime, its equivalent plain text is available. So this pair is available and this pair of data is available. Okay, so these plain text and ciphertext are selected by the dark to recover the EMP. Okay, all these data are based on same key. Okay, so that type of attack is known as chosen text. Okay, so if you build the crypto system, symmetric crypto system, definitely it should resist all these attacks. Okay, but we can grade the quality of the crypto system. The quality of the crypto system is based on this. Okay, the poor crypto system, even it won't resist chosen ciphertext. Okay, but very high-end crypto system, very high-end crypto system will resist even all these things. Okay, if it resists ciphertext only attack, all the crypto systems will resist ciphertext only attack. Okay, but poorly designed crypto system, it will resist ciphertext only attack, but it may be vulnerable to known plain text attack. Okay, if it is vulnerable to known plain text attack, definitely it is vulnerable to chosen and so on. Okay, so the level of quality is based on this. Okay, so whenever you design the crypto system, whenever you design the encryption algorithm and decryption algorithm, you need to keep one thing in your mind that it should resist all these things. Definitely, it should resist the chosen text attack. If it resists the chosen text attack, then that crypto system is a strong, powerful crypto system. Okay, because all the crypto system will resist ciphertext only attack. Okay, even with extra data, it is not possible for the intruder to break the crypto system. Okay, so high level. Okay.
Ma'am, what is difference between non-ciphertext and ciphertext only, ma'am?
No ciphertext and ciphertext.
First one and fourth one.
Okay, very good question. Ciphertext only is this is the cryptanalyst. Dark is the cryptanalyst. Okay, in ciphertext only attack, dark will get only this C. Only this C. Okay, so from this C, the dark need to recover P. This is ciphertext only attack. Known ciphertext attack means dark will get this C. Okay, dark cryptanalyst will get C. In addition to that, the dark will prepare some pattern of ciphertext. Some pattern of ciphertext. C prime, C double prime, C double, some different ciphertext, and its equivalent plain text also available with the dark. Its equivalent plain text is also available with the dark. Okay, so based on this pair of data sets, the dark need to recover plain text from the ciphertext. If ciphertext only attack, only the C is available. Okay, in a known ciphertext attack, in addition to C, some extra data is available because the same key K is used with this pair of data, and number of pairs also selected based on cryptanalyst perspective. By using this extra data, this is actually the idea is very simple. Idea is C prime transform into P prime, C double prime transform into P double prime. Okay, the dark cryptanalyst will exploit the relationship between these. Okay, relationship, that is differential relationship between C prime and P prime will be exploited, and the relationship between C double prime and P double prime will be exploited. Okay, C double prime and P double prime will be exploited. Based on that relationship, the cryptanalyst will guess P from C by exploiting that relationship. Okay, but in the ciphertext only attack, only one data is available, that is ciphertext.
Okay, ma'am, got it.
Otherwise, I will tell you like this, okay? Because understanding this is something important. The ciphertext is a paragraph of text, okay? Paragraph of English text, some English text, paragraph of text between Alice and Bob. Okay. Now the crypt analyst, the ciphertext, each and every character is replaced by some other character. Okay. For example, let me take a small common trigram, THE. Okay. The common trigram is available in P. Okay. That trigram is converted as let it be YMC. Okay. I said already, if the input is alphabet, output is also alphabet. Okay. So THE is replaced by YMC. Okay. Now the dart will get this YMC. Need to recover THE. Okay. So only YMC is available. The dart need to recover THC. That is completely impossible. Okay. But other thing is that the dart can select some known pattern which is already available. Okay. So for example, THEY, some other word. Okay. That is be replaced by YMCK. Okay. So THE, this is cipher C prime. Okay. C prime is THEY. Okay. P prime is YMCK. Okay. This pattern is available with the dart. This is a known ciphertext pattern. Okay. So by using this pattern, dart can exploit some relationship. What is the relationship? T is replaced by Y. Okay. And H is replaced by M. E is replaced by C. Okay. Again, I assume another ciphertext is available. Let it be that is a THERE. Okay. So T is replaced by Y, and H is replaced by 1 M, and E is replaced by C, R is replaced by some M, and E is replaced by C. Okay. Can you understand this? I will write it out here because it should be something clear. Let it be as P1, P1, C double prime or P double prime. Known ciphertext. Okay. What are the data are available? First data is THEY. Okay. What is the? I'm sorry. I did the reverse. Okay. The plain text is THEY and sequence ciphertext is YMCK. And another plain text is THERE and its equivalent ciphertext is YMC LC. Okay, so these two paths are available with cryptanalysts. Okay, so ultimately the cryptanalysts need to recover this YMC. Okay, so now here in this cipher, Y is available. Here also Y is available. Then Y is replaced by B, replaced by T. Okay, so that this Y will be replaced by T. Okay, that idea, cryptanalysts will get that idea by exploiting this relationship. Got it?
Yes, ma'am.
Clear? So that, but the cryptanalyst known blind ciphertext attack is not so simple like this. But this is one way. Okay, by exploiting some relationship between the existing ciphertext and plaintext, cryptanalysts will get some idea to recover the plaintext from the ciphertext. That idea to be exploited in the same ciphertext. Okay, so the ciphertext only attack, only the C is available, P to be recovered. But in the known ciphertext attack, some extra data. Either actually all these things remain same. Only one difference is that this is known plain text, equivalent ciphertext is available. This is known ciphertext, its equivalent plain text is available. And this is chosen plain text and its equivalent ciphertext is available. Okay, extra data will be like a pair, ciphertext plain text pair. Okay.
Yes, ma'am.
Okay. Actually, we'll do it for each and every symmetric ecosystem data. We will get a better understanding. Okay, because all these are based on frequency analysis attack, differential analysis attack, linear analysis attack. Okay, so max are good. Okay. I think with that intro, we get into a very fast symmetric cipher. C is a cipher. Okay. Actually, in classical cipher point of view, the first 4 classes we are going to discuss about classical symmetric cipher. First unit deals with the classical symmetric ciphers. Okay. there are around 7 classical symmetric ciphers. Actually, classical symmetric ciphers are classified into 2 types. Okay, one is based on substitution-based cipher, substitution-based cipher, substitution cipher. Another one is based on permutation-based cipher. That is known as transposition cipher. Okay, substitution-based cipher, the basic operation is only substitution. Okay, permutation-based cipher, the basic operation is only permutation. But modern ciphers are based on both substitution and permutation. Okay, under substitution category, the first very simple cipher, now we are going to discuss, very simple, within 10 minutes we can complete. That cipher is Julius Caesar cipher. Okay, actually developed by Julius Caesar. So Julius Caesar cipher, okay, it's also known as shift cipher. Shift cipher. Very simple. Okay, we'll do it now. We will discuss about the algorithm for Caesar cipher and cryptanalysis of Caesar cipher. Okay, let me get it on your slide here. Caesar cipher or shift cipher. Okay. So the Caesar cipher, whatever may be the cipher, we have to define 2 things. One is what is the encryption algorithm, okay, and what is the decryption algorithm. Caesar cipher is for English alphabet. What is this English alphabets? Okay. So encryption algorithm is based on very simple thing. Okay. So E is nothing but encryption algorithm. It takes plain text as an input, key as another parameter. It should produce cipher. Okay. So this is simply take it out the plain text and add the key. Okay. Then after that, do the model reduction with 26 because it is for English alphabet. Do the model reduction with 26. Okay. And decryption algorithm is D of C based on K key, which produces the plain text. This is equal to take it out the cipher text, subtract from the key, then model reduction on 26. Okay. Actually, in the second unit, we are going to discuss about modular arithmetic. Okay, we will discuss about modular arithmetic. But for classical cipher, 2 modular operations are required. One is we need to compute mod for negative number, modular reduction for negative number, and we need to compute multiplicating units. Okay, so for I will tell you that mathematical part because even we have enough time to discuss about modular arithmetic later. But negative number modular reduction. Okay, that part is required for this algorithm. Let's get into that. 5 mod 6. What is the answer? 5 mod 6. 5 mod 6.
5.
Okay. 7 mod 6. What is the answer?
1.
What you did, just to divide this number by this, the value is nothing but a reminder. Okay, so divide the number, find out the reminder. Now, if it is minus 7 mod 6, what is the value? Minus 1 mod 6, what is the value?
5.
5.
How that 5?
Add 6 until the number becomes positive. Add 6 to minus 7 until the number becomes positive. Minus 7 plus 6 minus 1. Minus 1 plus 6 5.
Okay. You have given a formula, but I will give you a simple timeline diagram, just one diagram, so that you can remember this. Yeah. Okay. For model reduction means finding out the remainder residues. Okay. So just see residue timeline starts with the 3. Let it be this is mark 3. So multiples of 3. 0, 3, 6, 9. Okay, so this side -3, -6, minus. If we take number line like this, number line diagram. Okay, not timeline, number line diagram. So this is Ma3 number line diagram. I need to find out 5 mod 3. Okay, so 5 mod 3, I'll plot it in the number line. Even it seems to be very simple. To understand this, definitely you'll never forget the negative number model reduction. Okay, very simple formula. I can tell you the formula right now, but you have to understand the reason behind the formula. That's why I have written number line like this. Some of you may know about this. 5 mod 3. Okay, where is the 5 here? 3, 6. So the 5 is somewhere here. Okay, so this is 5. Okay, so now what is the reminder? 5 mod 3 is something where 5 mod 3 is 5 mod 3 is 5 mod 3.
2.
So 5 mod 3 is 2. There is nothing but this value. This one, this part. Okay, so 5 minus 3, so which is nothing but 2. Okay, so for example, if it is 8 mod 5, 8 mod 3. Okay, for example, if it is 8 mod 3, I can plot it here. 8 is somewhere else here. 8 is here. The remainder is this region. This region is the remainder. Okay, so the 8 minus 6, 8 minus 6 is something like 8 minus 6 is 8 minus 6 is
2.
2. So that this is nothing but 2. In the same thing, negative number also follows the same scenario. For example, my number is minus 5 mod 3. Minus 5 mod 3. Not minus 5. Minus 5 is minus 5, minus 3, minus 4, minus 5. Minus 5 here is somewhere else. Minus 5 will be here. So minus 5, because minus 3, minus 4, minus 5, minus 6. So the remainder, not this part. Remainder is this part, this partition. Okay. So remainder is here. Okay. So I have calculated 5 minus 3 here. In a similar manner, here you have to calculate minus 5 minus of minus 6. That is nothing but 5 plus 6. What is 5 plus 6 here? Okay, minus 5 plus 6. What is minus 5 plus 6?
1.
1. So here minus 5 mod 3 is equal to 1. 5 mod 3 is equal to 2. Okay. So the remainder or residue is here. We'll discuss more about this later, the second unit. But the remainder to be like this. Okay. Let's go for one more case with a negative number. Minus 8, minus 8, minus 8 mod 3, minus 8 mod 3, minus 8 mod 3. So 8 will be here, somewhere else here. Minus 8 is here. So the remainder is this partition. So minus 8 minus of minus 9, that is minus 8 plus 9, that is also 1. Okay. So what Aditya said is same formula, but just imagine this number line diagram. You will never forget about this negative number model reduction. Okay. So Cipher is simple because we need to do the model reduction with the 26. Okay. But when you go further, we need to do the model reduction on n, which is very large. Okay, different number. So you need to know how to do the negative number model reduction. Negative number model reduction is most important thing in cryptography. Okay, so modular reduction. If you said modular reduction, definitely the result remainder any one of the value which is less than 10. Okay, starts with the 0, 0, 1, 2. These are the value of after modular reduction with 3. Okay, so we'll talk more about modular arithmetic property later. Let me complete the Cipher. That is a simple example. Okay, let's take an example for Cipher. I need to encrypt Shastra University. Let me be Shastra. I need to encrypt Shastra. Okay, so this is a plain text. I have to convert it into ciphertext. Okay, then it will be the key k is equal to, for time being I'm going to take 2. Okay, it's also known as a shift cipher because what they are doing here is encryption process, just they are shifting towards the forward direction. The decryption process, we are shifting the character towards the negative. That's it. Okay. So the key decides the number of shifting. Okay. So yes, actually this is a basic arithmetic. We can also do it by using basic calculation because all these characters will be replaced by its position. Okay. So you have to start with 0. A's position. Okay. 0. B is assigned with the value 1. C is assigned with the value 2 and so on. Z is assigned with 25. So the valid values are 0 to 25. We can also use ASCII value as some other value, but if you use ASCII value, the mode reduction in 26 is not possible. Okay, so convert this Shastra into a set of integer. What is yes? What is the position of yes? Arithmetical position of yes? Yes, yes. What is the alphabetical position of yes?
18.
Previous students of Shastra, CSC. Yes is nothing but alphabetical position of yes.
18.
A. A.
0.
P.
19.
P. R.
17.
Here there are around 56 students. Susma. Just to do the calculation like this, P 18, P1 is 18 plus K is 2 here, 18 plus 2, then do the model reduction with 26. Susma, give me the answer. What is this? 18 plus 2, 20, 20 more 26. Sweta, Raikun, Sherin. Cryptography, I would be like passive teach. Okay, I expect some answer from you because I won't do any hand coded calculation. All the hand coding will be by you. 18 plus 2 more 26 percent answer. $18 plus 2 more 26 what is answer?
U, ma'am. 20 U.
Just get number, integer number.
20, ma'am.
20. 20th character?
U.
What is the 20th character? U. So this first character is U. Okay. A, the position A is 0, 0 plus 2 or 26. Okay. So 2 more 26 is again 2. Okay. The second character is C.
C.
And yes, again, so they need not compute the second view because all these actually deterministic step cipher. T is 90 plus 2 mod 26. What is the value? This is equal to
21, ma'am.
21. So which is nothing but V. Okay. So this is 21. And again, A already we have computed. What is it? C. So the plain text Shastra replaced by this cipher as UCUBC. Okay, so the decryption is simply a reverse process. What is a reverse process? 20 is a ciphertext. We need to recover the plain text. Okay, so this is the encryption. For the decryption, the ciphertext minus key is 2. Then do model reduction with the 26. 20 minus 2 is 18. 18 more 26 is 18. What is the 18th character? 18th character is this. Okay, so we can recover it by using simple subtraction operation. This is cryptography. Okay, So to break this crypto system, you do not worry about cryptanalysis. Okay, because to break this, what is the only way by breaking the crypto system? What do you mean by breaking the crypto system? You have to recover the plain text from the ciphertext without using key. Okay, so very simple approach is here. How many possible key values? How many possible key values? How many possible key values?
26.
Only 26. You can take 27, but 27 is nothing but 1. Okay, so only possible key values are 26. Okay, so 26 key values are possible so that hacker can easily break this crypto system by using 26 trials. Okay, so 26 trials are enough. Okay, so this is not at all a crypto system, but a very first crypto system for the entire cryptology point of view, Cipher. Okay, so 26 keys are enough. 26 different trials are enough to break the crypto system. Okay, so ciphertext only attack is itself is possible. Okay, it won't resist ciphertext only attack. Okay, if with a given ciphertext, the hacker intruder will try 26 different keys to recover that. Okay, and moreover, trying the key is simply an addition, simply subtraction, whereas simple operation, subtraction, model reduction. Okay, that is also possible, feasible with a normal computer. Okay, so this is what a first cipher. This is known as shift set. Okay, so tomorrow onwards we'll get into the a strong classical symmetric set. Okay, so tomorrow we'll proceed with the degenerate set. Okay, I'll stop here. Any doubts so far? Let me know. Any doubts so far?